Hey everybody, it's Jenny from Norman S. Wright. In the last video, I talked about water coils a little bit, and I want to do a couple follow-up videos on that. This week, I want to talk about water coil circuits a little bit more. So let's get started. Okay, in my last video, I showed 1 and 2 circuit water coils. So let's draw those in right now. 1 circuit and the 2 circuit, and let's show the water in and the water out. So then the question today is, why wouldn't you just use 1 circuit? So in this 2 circuit water coil, the inlets and the outlets of the water coil would be connected to a header right here, and the water would be brought into the header, and that's what feeds the inlets and the outlets. Wouldn't it be easier if you just had 1 connection in and out? In theory, it could be built in a single circuit, but circuiting on water coil does a couple things. First, you want to get the inlet and the outlet to the correct side of the water coil. This is usually the same side of the water coil, so all your piping connections come to the same area. And second, as I mentioned in the last video, circuiting controls the speed of the water through the coil. So let's move this over a little bit. The water velocity affects the pressure drop and performance of the coil. Running 1 long tube like this would increase the pressure drop across the coil, which would affect the size of your pumps and increase the cost. The velocity is important for performance as well, because if the water moves too slow, you'll have laminar flow. This is where the water is all traveling smoothly through the coil and there's no turbulence in the tubes. Let's make a little bit of room here. Basically, the water splashing around in the tube is what transfers the heat from the water in the coil to the tubes. So if you draw this out, all this water is splashing around. It is connecting with the tube and it's transferring its heat. In laminar flow, let's draw this up here, there is water interacting with the tube at the edges where the tube is, but some of the water is traveling through the center of the tube and never touching the tubes to transfer their heat, so your performance is reduced. Laminar flow can happen below 1 feet per second, but that doesn't mean that increasing water velocities higher and higher are better. And above 6 feet per second, the water may be traveling too fast and your heat transfer also drops because your water is moving too fast to transfer all of its heat to the tube before it exits the coil. This also significantly increases the pressure drop of the water coil. So ideally, you'd have between 1 feet per minute and 6 feet per minute velocity through your coil. Now, most selection software would tell you when you might be at a velocity that could result in laminar flow, but it is something to keep in mind when you select your water coils. Let's bring this all back on screen now. That was the importance of water coil circuiting. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.